This video is based on the notes from lesson 3 that can be found on page 7 of your packet. Okay, so I want you to think a minute about the number 32. If I said, what's 32 divided by 4? I'm going to do this up in the top right-hand corner in case you can't see that I'm doing it. 32 divided by 4 is 8 with a remainder of 0. Okay, so we don't even usually include that remainder if it's 0. Since the remainder is 0, that tells us that 8 and 4 are factors of 32. So we're going to use that same idea. When something is a factor of something, it means that if you divide it by that, you should get a remainder of 0. Okay, so in example 1, it says verify that this is a factor. That means if we divide by x plus 6, we should get a remainder of 0. So we're going to do that. Now remember, when we're dividing by x plus 6, we have to put negative 6 in the box. And then we're going to take our coefficients from f of x. So 4, 15, negative 63, and negative 54. And we should get a remainder of 0. If we don't, we've either done something wrong or it's not a factor. Drop down this 4, multiply, add, multiply, add, multiply, add. And that's our remainder, and so it's good that it's 0. We have a remainder, constant x squared, just for future reference. Now, in order to verify that that's a factor, that's all we have to do. But it tells us that f of x equals x plus 6, which is a factor, times 4x squared minus 9x minus 9. If we multiplied this out, we should get the original f of x. Same thing as if I said 32 divided by 4 equals 8, then 4 times 8 equals 32. It's the same idea. Okay, so let's look at example 2. These are going to be more like the questions you're going to see on the test. X minus 4 is a factor, so it means when we divide by it, we should get a remainder of 0. It says to factor completely. So the first thing we have to do is we have to divide by x minus 4. So we're going to take our coefficients of f of x. Remember, it is a factor, so we should get a remainder of 0. If you are not sure of the process I'm doing, check out the video for lesson 2. It's called synthetic division. Okay, so we have remainder, constant x squared. So f of x equals x minus 4 times x squared minus 2x minus 3. Now when we're factoring completely, we want to check each piece and see if it can be factored more. X minus 4 is factored as far as you can factor it because it has a degree of 1, which means we can't factor anymore. Now this trinomial can be factored more. So this kind of goes back a little bit in time to unit 4 when we were factoring. We're going to keep x minus 4 the same. This x squared minus 2x minus 3 is a trinomial that has an a value of 1, which means we can put our two sets of parentheses. We have x and x because x times x equals x squared. We're looking for two numbers that multiply together to give us negative 3 and add together to give us negative 2. So negative 3 and positive 1. They multiply to give us negative 3. They add together to give us negative 2. Now each one of these factors is a prime factor, which means this is completely factored. It can't be broken down anymore. Okay, so examples 3 and 4 can be found on the link to the packet. You can just look and see how we finish those. We're going to take this one step farther and actually solve instead of just factoring. So this time, notice we're given a 0. When you're given a 0, you just put the 0 in the box. You don't change the sign. Given the factor, we have to find the 0 to put in the box, so we change the sign. So this, don't change the sign. It says it is a 0, which means that when we plug it in, we should get 0 as our remainder. And we do, good. So we're left with x squared minus 9. Now I'm solving this because notice it says find the other zeros. That's another way of saying solve. And so I'm solving x squared minus 9 equals 0. Anytime you're solving a quadratic, you have that equals 0 on the end. Now, we spent an entire last unit on different methods to solve quadratics. We have completing the square, quadratic formula, factoring, and we just solve for x. Now this one, since it's just x squared minus 9, we can just solve for x. So let's add 9 to both sides. So we have x squared equals 9. Square root. And remember, when we square root, we have to use a plus or minus. And so when we solve, we would get 3, -3, and -2. Okay, once again, you can find the missing examples on the packet, but I'm going to skip to example 7 just to show you this process again. This one we won't be able just to get x by itself, so we'll have to do something else. So the 0 is -3, so we put it in the box. Coefficients of f of x. Says it's a 0, so we should get a remainder of 0. Which we do. So we have x squared minus 5x minus 6 equals 0. Now, pick your favorite method for solving. Some people really like completing the square, quadratic formula, whatever you really like. Personally, I think factoring is the easiest if you can factor. So since there's a 1 in front of a, or there's a 1 in front of x squared, sorry, then I'm just going to try to factor. So we have x and x, and we need two numbers that multiply to give us -6 and add together to give us -5. So -6 and +1. Now, since we have x minus 6 times x plus 1 equals 0, that means that either x minus 6 has to equal 0 or x plus 1 has to equal 0. And this is all just stuff from unit 4 and 5. And so then we solve, so we'd add 6 to both sides, and so x equals 6, subtract 1, x equals -1. And so our two other solutions would be 6 and -1.